Hello everyone, welcome to Intrinsic Intelligence YouTube channel. Today we are going to discuss on microservices design pattern or a concept which is related to databases. CQRS, Command Query Responsibility Segregation. So how it works, when to use, when not to use, and what is its complexity. We will discuss in the further slides. First, have in mind like command query. So command is write, query is read. And how the responsibility is segregated, we'll move on into the next slide. So the core idea is in a command query responsibility segregation, it operates into two distinct models. Suppose you have a microservice for CQRS, it has two different models, one for read, one for write. In the right hand side representation, we have C for command and Q for query. C command writes the states, Q query reads the state. So the command side, what it can do, create, update, and delete operations will be run. So they don't return data on any success or failure. So on the query side, it actually modifies nothing and it can be optimized. So in the query side, it can read and returns the data where we can go for views and materialized views. If we implement on the query side, it would be of great help. Because when a write happens, so it would be eventual consistency, which we are going to discuss on the furthermore slides, which will notify through the queuing mechanism using Kafka or SQS or SNS. Then the materialized view will be updated and the read will happen much faster. So it is not stronger consistency. So it is an eventual consistency we can achieve using CQRS. Two models can be backed by different data stores, and these two models can be scaled independently. So consider we have a system where it is write heavy and read is very less performance low. So in that case, we can concentrate on scaling up write side and not on the read side. Where if it is read heavy, we can improve materialized views, catching, and how to make this eventual consistency near real time. Those kind of opportunities we can improve them. So it is a pattern, not a framework. CQRS can apply to single service internally or span across multiple microservices. We can keep both command side, the query side in the same microservice, or we can keep it at the different microservice as well. So now we will see the difference between traditional CRUD versus CQRS. So CRUD is create, read, update, delete. So what happens in a CRUD model is sends a request to the service. Service handles both read and write, and it sends the request to the database. So this is a CRUD model. What is CQRS? CQRS is optimized into two models, two separate stores. When the request received from the client, so the service is divided into command side, query side. When we see on the command side, it writes into the DB. When we see on the query side, it reads into the DB. Now, so this is the system architecture of how it works. We will go into detail. First, number one, client sends the request to the command side. It validates and writes into the DB. And in the second, client as parallelly sends the query side. So it will go to the query service. So we have command service, we have query service. Third, the command service writes the data into database after validating the data. Fourth, once the write has been successful, it pushes into the event bus stating the particular event has been updated into the database. So number five, it updates the database, and then, like I said, it can now get the updated data. So there will be a minor difference when the write happens and the updated data read happens. That's why it is eventual consistency, what I mentioned, not stronger consistency. Because consider if it is a write heavy and the client is reading it. So to get the updated data for the client, we need to see or wait until the event bus sends us the event so that it updates into the database or views or materialized views. So to have this updated data in terms of banking or payment service, we can handle it in UI with once the event is there and the read databases are updated, or we can also mention the data is processing. before providing the data into the UI. So this is on the command path step by step. So once the client issues the command handler or service validates and verifies the request or the query. Then it is write into the persistent DB for writing, and then event is published. So the write model where the correctness lives. So it is like domain driven aggregates or invariants or event sourcing. So then let's move on. So what about on the query side? So the client issues the query reads directly, the read stores into the projection, or it could be joins or aggregations or denormalization, and then response is returns to the client. So read, it can handle horizontally, it can scale, it can be stateless. So we don't also need any reportings or key value caches. So there is no business logic to run. If at all it is needed, we can go for indexing, even though it doesn't solve the performance or distributed querying problem. Then we can go for caches like Redis and so on. Synchronization. So keeping read and write in sync. So when the write happens, it sends the event bus. So it could be SNS or SQS or Kafka. Then the projector consumes and transforms and updates the read view. So a write happens. So until this process happens, right, the event bus and the projector updates the read view, client will get the outdated data. So in that case, there could be millisecond difference. We can use a loader in the screen until the event bus is successfully updated. We can give the real-time data. Suppose to achieve a stronger consistency, but it is works as a eventual consistency, whereas full consistency, then we can go with it. So what are the benefits of CQRS in microservices? So it is independent scaling, service autonomy. So basically it is event-driven microservices and communicate through events. And then technology flexibility. So we can use Redis, Elasticsearch, or PostgreSQL fault isolation, as slow or failing a read doesn't block commands. Like if a command side goes down, read can happen. If the read side goes down, command side write, update, and delete can happen. So the simpler read logic, and where we can just fetch and return the results. So we have all these 6 advantages. So independent scaling applicables when there are more writes, we can scale it up to 100 and also than compared to read. So independent scaling, optimized data shapes, service autonomy, technology flexibility, fault isolation, and simpler read logic. What are all the challenges? Like I said, the first thing is eventual consistency. So we have to, will not be able to get the data immediately. It will take milliseconds. So whereas we have to handle it in the UI, and more moving parts, because in CRUD, normal CRUD, create, update, read, and delete, it is a single system where we have command side, query side, pipeline, and the pipeline has to project or update the read view. So it is a more moving process and operational overhead. Once we have much more components into the architecture, suppose we have to have a scaling horizontal or vertical, and we have to have a backups, partitioning, consistency, and availability. We have to look into all these aspects. So debugging complexity. So when it goes down, then we have to go through multiple operations and we have to see multiple log IDs to see what happened, and data duplication. Read, store, duplicate data or outdated data until the write updates through the event sourcing mechanism. Premature complexity risk. So applying CQRS to a normal system where it can run efficiently using CRUD operations, it adds more cost to it. So these are all the challenges and trade-offs we have: eventual consistency, more moving parts, operational overhead, debugging complexity, data duplication, and premature complexity risk. So this is a decision guide, when to use CQRS and when you should not. So where it is good fit, where it read and write workloads are high asymmetric in volume and shape, complex logic on writes, and event driven architecture, we can go for CQRS. So if different clients need different projections of data, then we can go for CQRS when it is not quite a good fit. So when it is a small team and restricted infrastructure, then we should not go for CQRS. If a simple CRUD operations runs efficiently, we need not to update it to CQRS unnecessarily. And if a system needs strong immediate consistency, like balance checks, payment processing, banking systems, then we can mostly avoid CQRS. And if at all we are opting CQRS, then we have to work aroundly and handle it in the UI. If the domain logic is simple and we need one model, then we should obviously go for CQRS only. Thank you all for watching this video and have a very good day.